Hello guys and girls, we are back with another Solutions Architect interview question answer video. Questions we are going to cover today are: give me an example of a microservice design on AWS. What is three-tier architecture? Why should I use container if virtual machine has been around for so long? How did you do disaster recovery for your application? How do you secure your application on the cloud? How do you pick one service versus another as a solutions architect? What is event-driven architecture? How are you preparing for GenAI? Or what do you think of GenAI? And what is AWS Service X? For each of these questions, I'm going to go over some of the average answer that I hear a lot in interviews. If you give these answers, you may think, oh, I did good in the interview. But in reality, they are just average answers. So I'll also give you a better answer. And if you give your answers this way, interviewer will think that you have real-world architect experience. Each of these questions I have timestamps, so feel free to skip around. For those of you who are new to this channel, my name is Raj. I'm a principal specialist solutions architect working at AWS, coming up on my 6-year anniversary. I joined AWS as a general SA, and then I became a specialist SA for containers and serverless. Before joining AWS, I was a distinguished cloud architect at Verizon, where I migrated a bunch of projects into AWS. I'm also a published Udemy and Pluralsight author, but a couple of things I'm real proud of is I actually delivered critical real-world projects which went on to become official AWS references, and I also mentored students who got into top companies, including AWS and Google. Let's get started. First question is, can you tell me about a microservice you have designed on AWS? And a common answer I hear is, I will use application load balancer with EC2, or application load balancer with EKS, or API gateway with Lambda. What interviewer is looking for is actually how the microservice design works using those services. Because if you think about it, you can run a monolith using application load balancer with EC2, application load balancer with EKS, and you can jam a lot of functionalities in a Lambda as well and front it with API gateway. Just saying application load balancer with EC2 does not say the microservice design. And second thing, if you want to separate yourself from the pack, you should highlight how different microservice characteristics are reflected in the design that you have done. So let's take a look at a better answer. So you could say you have designed microservices using application load balancer along with Amazon Route 53. Route 53 URL that is pointing to application load balancer using the A record, and based on different path, different target groups are invoked. So for example, if the URL is www.store.com, so store.com/browse will go to one backend determined by one target group, which is running, let's say, Amazon EC2 in auto-scaling group, and the database is Amazon DynamoDB. If it is store.com/purchase, it's going to another target group, which is using same auto-scaling group with EC2, but with Amazon Aurora. And then store.com/return can go to another target group, which is using DynamoDB with EC2. So traffic for all these different microservices for /browse/purchase/return could be different. And you can design these EC2 instances and auto-scaling groups accordingly. So if /browse has way more traffic than /purchase or /return, you may use a bigger size EC2 there, or you will keep some of the EC2s running in those target groups. Down the line, the design is flexible. This is microservices. You don't have to use EC2s all the time. It's possible that different teams will maintain these 3 different microservices. So the store.com/browse may run in EC2. However, store.com/purchase was refactored using Kubernetes. Store.com/return could be used as Lambda. And another superpower of microservices, they are all independent of each other. And since different teams are handling it, they could be scaled independently, have separate security policies, and they could be developed using different tech stack. So store.com/browse could be written using Python. Store.com/purchase could be written using Node.js, and then the return could be written using Go. As you could see, this clearly explains the actual design of microservices using load balancer and EC2, EKS, and Lambda, as well as highlighting the characteristics. And this is how architects think. Moving forward, what is three-tier architecture? So this is the answer that I hear a lot, which is three-tier has three distinct tiers. One is the presentation layer, which is the front end. Next is the application layer, which is the back end. And then you have a storage layer, which is basically the database. So everyone says that, right? So to make your answer better than everyone else, again, following the logic, you need to show that how they're actually implemented in real world. So in addition to that, you should add that. So the presentation layer, one example could be, let's say Amazon.com is the actual website where you go browse different product. And the typical tech stack could be an Nginx web server or Apache web server. And then let's say you like an item in the front end and then you click add to the cart. And then the application layer is invoked. So some business logic needs to run. That could be run using like Java jar file or Node.js or Python. And it could run in Apache Tomcat or Oracle Web Logic Server, etc. And finally, the database depends on the application. It could be relational database like Oracle, MySQL, PostgreSQL, or even DynamoDB. And then I would actually give a design so that you are talking like an architect. So I would say, and a sample design of three-tier architecture on AWS could be, the front end is designed using application load balancer and with Amazon EC2 running web server. The backend could be implemented using application load balancer with Amazon EC2 running the application servers or business logic. And the database could be implemented using DynamoDB or Amazon RDS, whichever one you are more comfortable with. And then you can talk a little bit about how you will make it scalable and highly available. If you want to get more interview questions with real-world answers, please subscribe to my newsletter. And once you subscribe, you'll also receive this free PDF with a lot of different interview questions, the average answer and better answer, and you can use this PDF as your study guide before any big cloud interview. My free newsletter link in the description, or you can also go to cloudwithraj.com/newsletter to sign up. Back to the video. Okay, the next question, this one is becoming more and more common. Why should I use container, or how is containers different than VM? So one answer I hear is containers are scalable, lightweight, portable, secure, and cost efficient with better resource utilization than VM. You do not need to manage infrastructure when you run containers, unlike virtual machines. And Kubernetes is becoming very popular because of this reason. Now remember, only because you are trying to highlight container, you do not need to shit on VM. And that is not the truth. So what the interviewer is looking for is explain the why. So you said containers are scalable, containers are portable. Why is it, right? And secondly, container and virtual machines go hand in hand, and you should give an example. So to go over an actual answer, you could say containers are very popular these days. Some of the big reasons are containers don't have host operating system in it, so it's lightweight. And since the code, dependencies, and libraries are all packaged inside the container, they are very portable and can run in multiple clouds, on premises, and even on the edge. See, I'm not just saying containers are lightweight, containers are portable. I'm actually telling the interviewer, why is it lightweight? Why is it portable? And then look how I am tying the container and virtual machine. However, container and virtual machines go hand in hand. For example, the most popular container orchestrator, Kubernetes, the worker nodes actually run in virtual machines, whereas the containers run within the pods inside those virtual machines. So this is a totally misconception that if you go containers or Kubernetes, you do not need to manage virtual machines anymore. Let's say Amazon EKS, AWS manages the control plane, right? So let's say this is control plane, CTRL plane, ignore my handwriting. AWS manages this, and this part you do not need to manage. However, the worker nodes of the data plane, they are still EC2, right? They are still EC2. And your containers are running inside a pod inside those EC2s. And these EC2s are running with AMIs. And AWS provides you with AMIs like AWS provides you with regular EC2 AMIs. So let's say you are running with Amazon Linux 2. And if there is a security vulnerability, you still need to go rehydrate this AMI, upgrade it, patch it, all that stuff. So this part is not different than running your application on EC2. So don't say that when I move to container, you don't need to manage any infrastructure. Next question. How did you do disaster recovery for your cloud application? And the average answer is, I will just replicate it to another region. This is a very blanket statement, and this does not show the depth of knowledge that an architect needs to demonstrate. Actually, I have done disaster recovery for multiple applications. There are multiple other factors. So how should a good answer look like? So good answer will be like, there are different options to choose for disaster recovery depending on RTO, which is recovery time objective, and RPO, recovery point objective. So for lower priority use cases where the RPO and RTO could be longer, I will use backup and restore, and then say pilot light, warm standby, multi-site, active. And you can study more on those here. And then I will actually give an example. And then I will say, hey, I worked on a critical project where the RPO, RTO needed to be real time, and I implemented multi-site active. Then you can study this example. I have given the link so that you can talk about it, that hey, with a multi-site active disaster recovery, I'll have the same architecture running in 2 different regions. Let's say, for example, the application load balancer are fronting the traffic, and I will have Route 53, and depending on the latency, it sends the traffic to one of these load balancer. So if one region goes down totally, it will automatically switch the traffic to the other region. And then you have auto scaling group, application server, front-end server, and then the database DynamoDB is using global table, which is a bidirectional replication. If you are comfortable with Amazon Aurora, you could say Amazon Aurora here as well. That also has global table. Now, one thing is, I don't know if you guys notice, there's a problem with this diagram. This is official AWS diagram. See, front-end servers are directly talking with application server, which is not the best practice. So there should be an application load balancer in between. So front-end should send traffic to ALB to the backend. Today I'm recording this on a Sunday, so maybe I'll talk to the team responsible for this diagram tomorrow so that they can fix it. But anyway, jokes aside, hopefully you got the idea. Mention RTO, RPO, the 4 DR strategies, and then study one of those DR strategy in detail so that you can say the implementation. Next question, how do you secure your application on the cloud? So the average answer would be like, use KMS, IAM, and firewalls for security. So the problem is, explain what they do rather than just saying service names. And then take one application, such as 3-tier app with EC2, or microservice running on Kubernetes or serverless, and explain in detail. So a good answer might be like, assuming my application is running in a serverless manner, so all the APIs are hosted in Amazon API Gateway, and all the API backend are handled by Lambda, and then that Lambda is going to different DB2s. So I've created 3 different color arrows to show that there are 3 microservices running. And then you could say that on the user side, I will implement authentication. I will secure data at transit using SSL TLS. On the API gateway, I will implement the authentication and authorization layer. So look up my video on API gateway authentication and authorization, and then the security of data at rest. So basically you will encrypt the data at rest using KMS. And the most important part is the security of the application, because this is where you'll probably get most of the questions, because this shows that you have actually designed and worked in an application. So I'll go over an example of security of the application. And I will use Kubernetes for that because Kubernetes is super hot right now. So generally in Kubernetes, you have your application container image running within a pod. and then that pod is running in the data plane, which is Amazon EC2. So application security for Kubernetes will look like you will use namespaces to divide the cluster. You can separate resource quota and access for each namespace, but for a multi-tenant cluster, by default, all pods can talk to each other. Use network policy to control pod traffic. You can control traffic by IP, label, or namespace. And then you implement RBAC or role-based access control. You can specify separate roles for separate groups such as admin, developer, tester, etc. Do not allow privileged escalation. Prepare for questions on privilege escalation versus root access, and use OPA or Open Policy Agent to enforce restriction. OPA will ensure that the images are coming from approved repository, and if you have namespace should have a label with point of contact in case something goes wrong, etc. So the point is, have one application ready in your head. How do you pick one service versus another as a solutions architect? So this is probably the most difficult kind of questions in an interview, because this comes up a lot during the system design round. So in that case, you need to ask interviewer about the design requirements for the functional and non-functional requirement. And there is no shortcut for this one. I wish I could just give you like the answers I just gave you for the previous questions. You just have to study for this one. And I have a bunch of videos on this one: load balancer, API gateway, serverless EC2, when to use event bridge, SQS, SNS, etc. I'll give the link to that playlist up top. So just go study. I also have some sample system design video, like how to design YouTube, Netflix, WhatsApp, etc. Check that out. I also talk about why I'm using this service versus the other. Next, what is EDA or event-driven architecture? Average answer that I hear a lot is EDA is event-driven architecture. One such example is messages going to SQS and Lambda processing them. See, this is not highlighting a couple of things. So one is, if you have worked in any real-world project, most project always consider synchronous architecture, okay? And it takes some amount of design consideration and work to go to EDA. So when you are giving this answer, you need to mention the superpowers of EDA so that interviewer knows that you have been through those conversations and you have convinced some folks to implement EDA. So if we take a look at a synchronous microservices, which could be implemented using load balancer or API gateway, with Kubernetes, EC2, Lambda, etc. So if we take one of those options, you can pick one that you are comfortable with. For example, a synchronous microservice could be API gateway, sending traffic to AWS Lambda, and the backend is Amazon DynamoDB. In this synchronous architecture, all the components in this design needs to scale up and scale down at the same time. So if the traffic increases, the API gateway needs to scale up, Lambda needs to scale up, and DynamoDB needs to scale up at the same time. So let's say at a certain point, API gateway can handle this increased traffic, because API gateway can handle by default 10,000 per second, which is pretty high. But let's say AWS Lambda reached the concurrency limit. Then the transaction fails and there is no retry built in. So what are some of the challenges of a synchronous architecture? All components of synchronous architecture must scale together. If a transaction fails, this customer or consumer needs to resend transaction for reprocessing, and it is expensive, because now you may need to increase the throughput of this DynamoDB. You need to have a higher concurrency limit. Maybe you need to have provision concurrency in this Lambda. So it increases the cost. If you break it down with an event-driven or a synchronous architecture, in EDA, you decouple the producer and the consumer of the messages. So in this case, API gateway is sending the messages to Amazon SQS, and then Lambda is consuming the messages at a rate not to overwhelm the concurrency limit of the Lambda as well as the backend database. So more messages could come in, API gateway can scale up, put all the messages into SQS, and then the consumer or the processor of these messages, which is AWS Lambda and DynamoDB in this case, can consume them at a rate that they can handle. So what are the advantages? The message producer and processor can scale independently, and retries are built in, because let's say the SQS, a message is sent to the Lambda and then that message is not processed, it will automatically be pushed back to the SQS and Lambda will retry. Whereas in synchronous, you or the customer needs to resend the message. Also, this is more cost effective than synchronous architecture, because you don't need to consider for a higher scaled up Lambda concurrency, higher scaled up Amazon DynamoDB. So you save a bunch of money. Okay, next question. What are you doing with GenAI? So bad answer is, doesn't matter how comfortable you feel in the interview, don't say this. Even if you believe it, you cannot say that GenAI is mostly hype. I have used ChatGPT, but I'm mostly waiting to see if the hype dies down, and then you chuckle or laugh a little bit, hoping that interviewer will agree. Because you do not know if the interviewer really likes GenAI, or if the interviewer really invested a lot of time learning GenAI and now you just called out GenAI a hype. Feel free to do that with your friends or your wife, but not to your interviewer. Okay, so one good use case to keep on your back pocket is, whatever industry you are in, you will always have a use case for RAG, or retrieval augmented generation. So let's say you are in the insurance industry. So you could say that, yeah, I am actually exploring GenAI. I use ChatGPT for my daily use cases, but actually in my project, we are doing a proof of concept or exploring the idea of implementing RAG. And then you study RAG. I'll go through it real quick. So you know, with ChatGPT, whatever ChatGPT model is trained on, it gives you an answer. But let's say in your insurance company, you want the answers to be specific based on the data that you have. So if we go through the numbers, number one, you get all the company data, files, databases, etc. You convert them into vector embeddings and save them into a vector database. And then you ask a question related to insurance cases. And before this code goes to your LLM, you could have it in Amazon Bedrock, it actually goes and retrieves the relevant information related to the prompt from this vector database. And then number four, you augment the original prompt with whatever you retrieve based on the company data. Okay, and then it goes to this LLM hosted in Bedrock, and then the answer comes back. So you could say that the answers are more customized and based on the company information. So advantage of this use case is it's easier to implement, and this is not as intense as tuning your model or creating and training your own model. So if you say that, hey, yes, I can fine tune my model or I can train my model, the problem is if the interviewer asks you a follow-up, you are kind of screwed unless you really know those things. Whereas RAG is easier to master. You can handle even a detailed follow-up question. Okay. Next is, what is Service X? So interviewer may say, hey, do you know what is CloudFormation, what is EC2, etc.? And people fumble so much. This is what I do myself. You say the official definition and then you can explain it in your own words. So for example, I have a bunch of these memorized now. So let's say Lambda, right? A lot of you like Lambda. I always say AWS Lambda is a serverless compute service that lets you run code without provisioning or managing servers. So I always say this part, and then I will expand a little bit, right? I will say, and it has some other advantages, such as it's pay-as-you-go, it scales automatically, it's inherently highly available under the hood, right, etc., etc. And based on the discussion or based on your project, this is actually a good service to consider. But if I don't say this initial description, you don't want to falter, right? So if someone says, hey, what is S3? You don't want to just say, oh, S3 object storage stands for this. Just memorize these popular ones, right? Amazon Simple Storage Service or Amazon S3 is an object storage service that offers industry-leading scalability, data availability, security, and performance. Then you can go forward and explain that I have used S3 with Lambda, S3 is also serverless, pay-as-you-go, life cycle, etc. All right, folks. So hopefully this was helpful. If you like this video, check out my other interview preparation videos, and I'll see you guys and girls in the next one. Bye.